Okay, this is number 4 from the proof worksheet, proving a quad is a parallelogram. Alright, we're trying to prove that A, B, ZX is a parallelogram. Now I've marked all of the given information, but if I can prove these triangles congruent first, which I will do that, and use their parts to get parts of this quadrilateral that I need, that would be one way of going about doing this proof. So I only put in the part of the given that I'm actually going to use to prove these triangles congruent. And of course, I can mark that angle 1 and 2 are congruent because these are vertical angles. So I think that's what I'll go ahead and put down next, that angle 1 is congruent to angle 2. That's because vertical angles are congruent. Alright, now I could say that these triangles are congruent. I'm going to name the triangle BYZ. And if I name it like that, the other triangle is going to be CYX. And that's because of the side angle side postulate. Okay, I'm going to use the parts of those triangles, and the parts that I'm going to use is going to be ZB and CX. And that's because corresponding sides of congruent triangles are congruent. Now, in the given, I did not write this down as step 1. I could have. I know that AX is congruent to CX. So that was again given, and it could be step 1. I think it's easier to realize now that I can use the transitive property and say that ZB is congruent to AX. And that's just the transitive property of congruence. Alright, now that will give me these congruent here. So I'm just going to mark them again on my diagram so I can see I've got one pair of opposite sides congruent. Well, if I can get those pair of opposite sides parallel, then that is one of the combo method for proving that a quad is a parallelogram. So if I look in my triangles, I see that 3 and 4. Now 3 and 4 are going to be corresponding angles because they would lie on top of one another. They would match up. So I can now say that, and I could have put this in step 4, but I'm separating it. Angle 3 is congruent to angle 4. And that's because corresponding angles of congruent triangles are congruent. Well, that actually makes a Z, and it gives me parallel lines. So that means that ZB is parallel to CA. And so I could say that if two lines are cut by a transversal and alternate interior angles are congruent, then the lines are parallel. Right now, even though XA is the side that I want to prove parallel to ZB, since XA is a part of CA, I can now say that indeed this has to be a parallelogram, because when I mark my figure, I'm marking these right here. And so XA is a part of CA, so to me this is the combo method. So that proves that this quad, ABZX, is a parallelogram. So I'm going to write ABZX is a parallelogram, and the reason is going to be the combo method, which states if a quad has one pair of opposite sides, both parallel and congruent, then it is a parallelogram. So that is one way to do that proof. It is not the only way to do this. If you just put in 5 with the given, then obviously it would only be 8 steps. Hopefully that helped.